Hello.
Yeah, hello.
Right. So that fan in, fan out. Okay, you need to prepare your answers well. How you can exactly put into the proper words. Okay. You can mention that to make the automation, you can write one script, automated script using Tickle, just to check fan in up to 2, 3 levels of the macro.
Can we do fan in up, fan out for all those 1,000 macros also?
That's what we can put into the script. We can run the for each
Mm.
loop. So for each macro, it will automatically run it and it will give 2, 3 level of the fan out.
Okay, okay.
Okay. So
Mm.
you can mention that this will give more detailed connectivity in understanding. Now you did not mention anything about the macro channel. How will you decide the channel, right? Also, one of the guideline is at least one vertical VDD in VSS should be present in macro
Mm.
channel.
Mm.
Okay. See, an interviewer also know that yeah, macro placement is iterative process, but what exactly you will do? Okay,
Okay.
your approach he or she want to know. Okay, clear?
Yeah.
Okay, scroll up. Let's check with the question number one. Okay, quickly we'll go it. Okay. Hmm. Yeah, sixth number question.
In placement stage, we require STC file. No, we cannot do place design without STC because
Okay.
we need a at least uh, like estimated timing to place the cells across the design.
Okay. So if we don't provide
I
SDC,
think
will it give
STC
error?
STC is required in synthesis stage only, right? No, if you are doing physical level synthesis, then STC is required.
Mhm.
But if you're not giving STC, I think we can proceed. But it so the placement does only with the congestion aware, not the timing aware placement.
Okay. See, if you don't provide SDC, tool will not have idea of the clock about clock, right? What is your clock period? So launch age, capture age, that is not defined. So tool will not do any timing analysis. Okay. So tool cannot do any optimization with respect to timing.
Yeah, but it can do congestion and all, right? When it can just place and just do uh, it can just do placement.
Yeah, only optimization with respect to other factors can be possible, but tool will not do any timing perspective. Okay. So,
Yes.
Sundarya, you can try to run one experiment. Okay. Don't
Okay.
give SDC. Try to
Okay.
run place of. Let's try
Okay.
to observe one by one error or warning in the log file. Okay.
Okay, sure. Sir.
To get that answer.
Okay. 2 runs I need to start today
Yes.
without STC and one with the magnetic placement. Okay, I will do that then.
Right. Scroll down. Scroll down. Okay. Scroll down. Hmm. Let's see. Yes, 19 number.
What point? We have to first check why the congestion is coming. Is it due to cell density or pin density? Uh, if
Mhm.
if it is due to cell density, then we have to check why. why those many cells are sitting in a particular region. Then we have to
The question is not how to fix the congestion. Okay, question is saying how will you analyze or root cause for the congestion.
first we have to check it. Is it the cell density or pain density, right?
That's what. How will you exactly will check it?
Based on the GRCs, overflow and GRCs.
Okay. See, first of all, you will open the GUI, right? You will load the congestion
Yeah.
map. You will
We
understand the
have
hotspot.
we have a
Report
condition
congestion map
hotspots.
again.
Right. Okay. So yeah, I mean this thing here, the expectation. Okay. Fine. So yeah, 27 number. Okay. That is device physics or conceptual questions.
I will use a higher duration buffer and
Mm-hmm.
buffer to fix timings and low duration for higher drop fixes.
Okay. Any other difference? Think in terms of advantage and disadvantage. Okay. Of this high time buffer, low time buffer with respect to PPA, power performance area.
Okay.
High drives and buffers will have more area compared to low drives and buffers.
Okay.
It occupies more area, but it helps in timing. Then for power optimization, uh, low drives and buffers are only used, right?
No, I mean where are we are using, that is not the question. Okay. Question is what is difference. Okay. So high time buffer, low time buffer, power will be same for both the buffer or it will be different.
It will be different.
So different, then yeah, which cell will have a higher power?
In the low duration buffer, we have a lower leakage power.
Okay, and what about the other power? Dynamic power?
Dynamic also will be low. Dynamic and leakage power will be low in the lower drive synth.
Yeah, so total power consumption will be less in the low reactance cells.
Yes, correct.
Okay. Okay, fine. So scroll down. Yes, 31 number.
What are the components will you see?
I
in
need
the-
detailed answer, okay?
We can see DRVs, transition capacitance, and fan out, and then mainly cell delay, net delay, start point, end point, uncertainty clock period. Um, Data required time, arrival time.
Okay, good. Anything else?
These start points are clocked if they are clocked by the same clock and clock to Q delay also.
Yes,
Logic
correct.
level.
Start point clock, end point clock, logic level. Right. Even if you use the crosstalk switch, you will see the crosstalk as well. Okay. Okay, perfect. So that you are able to mention. Okay, scroll down. Yes. Yes, 36 number.
Number of families.
So see, I think this command try to practice. Okay, 36. We'll
Okay,
discuss
we can
next time.
number of AND gates. We can take that resistor and do fan into that and grep only AND gates, right? Which grep only A and D from the that script and do size of collection.
Okay, one thing is you cannot use directly grep command in the tool. Okay.
Pickle, yes. We can if command or something we can use.
Yeah, try to think. Okay, like how to we'll practically understand next time. Okay, just scroll down. Yes, now 50 number question we have discussed that if we upsize the cell, like high dimension cell will have more dynamic, more leakage power, right? So this question is how high distance will have the more leakage power or more dynamic power.
Because it takes less current.
Less current, then how power consumption will be more? So whatever you are saying, right? Always try to ask yourself question that how, why. Okay, one small hint. See, if your cells is bigger, you will have the output capacitance, right? That output cell cap will be big. Okay, so to charge that capacitance and discharge that capacitance, it will take more time. Okay, basically, if 0 to 1, it will take more time from 0 to 1. If this time duration is increased, of course, during this time, your NMOS, PMOS both will turn on. And that's why your leakage power, dynamic power or short circuit power will increase. Okay. Now, if cells are bigger, if you go to device level, in your flow, you will have the transmission gates. Okay. So if you increase the drive stance, of course, number of transmission gate will be increased. And each gate will have the small leakage power. That's why If you upsize the cell, your leakage power will increase. Clear?
Yes.
Okay. Yeah, now this 55 number question, I think you should know it, okay? What should be the answer?
Which design having more boundaries?
Doesn't depend upon the clock period only.
Okay, so code variation will be same or different?
The same.
Right, 90% answer is correct. Okay.
It only depends on the skew, uncertainty, and all.
Yeah, I mean everything is same.
Skew, yeah.
Let's assume.
Yeah, generally it doesn't depend upon the clock period. But
Okay, one
only
thing is see.
only during half cycle paths for hold
Yes,
we'll
that's why
have hold
it can
variations.
affect, right?
Mm.
Okay, good. Scroll down. Scroll down. Okay, scroll down further. Okay, this we have discussed. Okay, scroll down. Hmm. Okay, scroll down after 94. Okay. One question related to ST and timing clock only, but let's see. Scroll down. Uh, 112.
How to decide optimum height and width of code?
Generally, utilization should be around 0.6 and 0.6 60% so that we leave the 40% space for routing. And how to decide optimum?
Okay,
We
see,
need
it
to
is
get
mentioned given aspect ratio and utilization. That means utilization, let's say fixed. But how
Mm.
will you decide your aspect ratio? Okay.
Aspect ratio should usually be AR equals to 1, and it should be a rectilinear, and it should usually we'll prefer square or rectangle.
Yeah, but in
For
rectangle
better
also we can have two, right? Wider rectangle, taller rectangle.
it is more than
so
width.
it,
This rectangle. Vertical rectangle.
Why vertical rectangle?
If height is
depends on the generally the how the module will sit, right? If the registers or pipeline is very big, then square cannot accommodate that, then that might cause a routing congestion or something. For proper timing, for timing, we have to, to reduce the congestion and timing, we have to use a square.
No, so you are saying only vertical rectangle is better or what?
Um, uh, No, in general, I'm not. I'm telling.
In general, vertical is better.
No, I'm telling it. It depends how the module is sitting and all.
Fine, but
I mean, also the port placement matter. If the ports
yes,
are
multiple
top
factors
and
are there.
bottom,
Okay, good.
then wider would be the better. Or if it is ports are on the left and right, then the taller would be better.
Right. Also, you need to understand the macro dimension. Okay, macro are taller or wider.
Yes.
If macro
If
is taller, you
macros are,
cannot have horizontal block. Right?
yeah, it should be the wider block, right? No, it should be the taller block.
Okay, perfect. Okay, good. So yeah, Soundarya, please try to run those two experiments. Okay. So based on that, we'll understand the results. We'll analyze the results. Okay.
Okay.
Okay, fine. And in your run article, keep uncertainty 100 picosecond only. Okay, so that we'll have violations.
Okay.
Okay, fine. Okay, then yeah, that's it from my side today.
Thank you.
Thank you. Yeah.